method. So Euler method basically means that from an initial point x naught, y naught, the method uses the slope that I've drawn over here on the graph to move forward in steps of size h to approximate the solution at the next point. So this graph over here basically explains how Euler method works. Now I'll move on to how I've derived these values over here. So for this question, I've used step size of 0.1. And with the initial value y bracket 0 equals to 1, I can tell that when x is equal to 0, y equals to 1. So I've keyed in over here, x is equal to 0 and y equals to 1. Then I want to be able to use these two formulas in order to find x1, y1, x2, y2, so on and so forth, so I can find all these values over here until I get my final answer to be 1.911. So using this formula, how it works is xn equals to xn minus 1 plus h. H is the step size. Xn is what you want to find, and xn minus 1 is the previous x value that you find out. So in this case, how I've gotten 0.1 for x1 is because I've taken 0, which is xn minus 1 in this case, and I've added 0.1, the step size, to it. Then for x2, I did the same thing. I took the value of x1 now, and I added the step size to it, which is basically 0.1 plus 0.1, so I can get 0.2. Then I done the same thing for the next few times till I reach 1. Why did I stop at 1? Because that's what they're asking me to find. Because when x is equal to 1, that's when we can find the value of y1. We can approximate the value of y1. So for yn, what I've done is I've used this formula over here. Yn equals to yn minus 1 plus h, which is the step size, multiplied with fxn minus 1, yn minus 1. This part over here basically means that you have to take the previous two values for x and n and sub it into the dy dx in order to find the next y. So in this case, example for this one, this is my y2 value. I've gotten it to be 1.1918. So to find this out, what I did was I took the previous y value, which is 1.1, plus the step size, which is 0.1, multiplied with 0.1 squared plus 1 over 1.1. Because I've taken the two previous values, subbed into dy dx in order to find this. And I repeated it so till I can find what they're asking me to find, which is 1.911 when x is equal to 1. So the approximate value of y1 in this question will be 1.911. Okay, moving on. Now I want to show you my solution for using the general solution. This is the exact answer that I've gotten, which is 1.91485. This is the exact solution. But I've noticed that my value is a bit different from the exact answer. I've gotten it to be 1.911 when I've used a step size of h. So I want to also try to use a different step size. And I've done another step size of 0.2. And I noticed that after doing everything with the formulas, I've gotten it to be 1.9093, which is lesser than 1.911 and very much lesser than the exact answer. So from this, I can know that by using a larger step size, there is more approximation error in y1. So I've written over here, the larger the step size, the more inaccurate the reading of y1 will be. That is the end of my presentation. Thank you for listening. Have a nice day.